Okay, in this video we're going to look at sine and cosine special angles on the unit circle. Okay, so last time what we talked about is in particular 45 degrees, 30 degrees, 60 degrees. So let's just start talking about 45 degrees, let's just do that. Okay, so 45 degrees is, as shown, it's splitting the right angle, bisecting it. And we discovered last time that the coordinates on the circle where 45 degree the angle intercepts the circle are rad 2 over 2, rad 2 over 2. Okay, now what we're going to do is extend this line here, and actually we're going to draw another line over here. Okay, now what am I doing this for? So, okay, if I take this 45 and I add 45, I get 90 degrees. And I add another 45, I get 135 degrees. And then I get 180 when I add 45, add another 225 degrees, 270 degrees. Made that line a little long there. Anyway, that's then 315 degrees. And then over here, 360 degrees. Now, the angles that we make with these axes are 45 degrees with the x-axis. And we can also draw a right triangle. We did that last time, or we don't really have to. But what I'm going to do is I'm going to try to find the x and y coordinates for these points, 135, 225, and 315. And what we can see is that if I do draw a triangle, it's a right triangle, we can see that these triangles are congruent so that the lengths on the sides are the same. This is a unit circle. And so that if I go to the left to reach this point, I'm going to go to the left by rad 2 over 2. Well, see, I mean, it's the same distance to the right to this point over here, 45 degrees, as if I'm going to the left to 135 degrees. So, but the thing is, since it's to the left, I put negative. And then I go up exactly the same amount, so that's rad 2 over 2. So remember that in quadrant 2, we have that x is negative and y is positive. And now over here, we have these same numbers because you can also draw a triangle, but the triangle sort of makes it messy in a way. But anyway, you can see to go, how far am I going to the left? The same far I'm going to the right to get to this 45 degree angle. I go to the left by rad 2 over 2. I go down by the same amount I went up. So that's negative here. And this is in quadrant 3, where both x and y are negative. And then over here, the 315, I'm going to have by the same reasoning, rad 2 over 2, negative rad 2 over 2. Remember in quadrant 4, x is negative and y is positive. You can put in the parentheses. Sometimes I do that. Okay, so what's the deal going on here is that, remember that the x coordinate is cosine and the y coordinate is sine. So therefore, we have that cosine of 45 degrees is equal to rad 2 over 2. Sine 45 degrees is also equal to rad 2 over 2. And then you can just do all of these points here, these angles. Cosine 135 degrees is therefore negative rad 2 over 2. Sine 135 degrees is positive rad 2 over 2. I mean, you can find these on the calculator, but I really believe that it's a good idea for us to have some sense of the unit circle. I think you can really understand a lot more. And besides that, you can do these things in your head then, if you understand what's going on. So again, the x coordinates cosine and the y coordinates sine. So the big issue is that is this idea, is it positive or negative? See, these are all the same numbers. It's just they vary for positive and negative. And so what you can do is say, well, we talk about, well, look, here's 225 degrees. What angle does it make with the x-axis? It makes a 45-degree angle. And then we come back to the 45 degrees, find the x and y coordinates, and we adjust them positive or negative depending on the quadrant they lie. So what the idea is that you look at the angle and you compare it to the x-axis and you find the difference. 225 minus 180 is 45 degrees. And then you compare that 45 with this over here. Pick up those numbers, but adjust them for positive or negative. This guy here is called the reference angle. 45 degrees is a reference angle. Now, the thing is that that's all done in degrees, and not very long, I just completely give up on degrees and move on to radians, because that's actually what the natural world is based on. It's not based on degrees. So half of pi over 2 is pi over 4. And so what we can do, it's not really my best effort there. Okay, so that gives us rad 2 over 2, rad 2 over 2. And what you can do then is fractions. You start adding 1/4, 2/4, 3/4. As we saw before, it also has rad 2 over 2, rad 2 over 2. But we adjust negative for the x coordinate because it's in the quadrant 2, positive for the y coordinates. Then this makes 4/4 pi, which of course is pi. Then 5/4 pi, and we get negative rad 2 over 2 over 2, negative rad 2 over 2 over 2. Same numbers, same coordinate numbers as here, except because of the quadrant in which it lies, x is negative, y is positive. And then over here, 7/4 pi. Okay, so this is 6/4 pi, which is, of course, is 3/2 pi. And then we have 7/4 pi, and that corresponds to positive rad 2 over 2, negative rad 2 over 2. And it's enough for me to do this. I could fill in and say, well, what's cosine and sine? So, but just remember that cosine is the x coordinates, and and sine is the y coordinates. Okay, so that's in radians. Let's do another video, the next video where we'll do 30 degrees and 60 degrees.